Okay, gang, so we are now today going to talk about 6.6, which focuses on linear equations. Okay, and so this is a big lesson. If you took a look at the PowerPoint that I attached to Canvas, you saw that it was 32 slides. So it's quite a bit of information. Within this video, I'm going to focus on the 3 ways to graph linear equations that they talk about within the PowerPoint. And so the 3 ways that they talk about, the first way is just by plotting points. Plotting points. Okay, and we'll talk about that first. The second way is by finding the X and Y intercepts. X and Y intercepts. And so that's the one that I usually see kids struggle the most on, okay? And then number 3, it talks about getting a linear equation in slope-intercept form. And I know you've heard the word slope-intercept form at some point in high school. And I like to just call that SIF for slope-intercept form. So if you see me write that today, SIF and slope-intercept form pretty much mean the same thing to me, okay? So the first way, talking about plotting points. Okay, so let me give you an example doing this. So if I give you y equals, let's just make something up, 2x minus 1. Okay, so plotting points means we're going to make a table, an XY table, and you may or may not have seen me do this before. We'll make an XY table. And guys, we can pick any number we want to and plug in for x. And so usually if I was teaching this in class, kids would say, any number in the whole wide world? And I'd say, yes, but let's think about it. If we were to plug in the number 10 right here into x, guys, we'd have 2 times 10, which is 20, and 20 minus 1 is 19. And that's kind of a large number. So I like to pick smaller numbers like 0. 0 is a really small number. 1 and 2. I use these numbers all the time because they're small and they're positive, and usually students are better at plugging in small positive numbers. Okay, so 0, 1, and 2. These are not magic x values. These are just x values that I like to use. Okay, and so that's exactly what we're going to do. Everywhere we see an x, we're going to plug in 0. So if I rewrite the equation was y equals 2x minus 1. And so when x is 0, it will be y equals 2 times 0 minus 1. Well, think about that, guys. That's y equals 2 times 0, we all know is 0, minus 1, which means y equals negative 1. So when I plug in 0, I get out a negative 1. Okay, let's go do it again. Again, the equation is y equals 2x minus 1. And now we chose to plug in 1, so y equals 2 times 1 minus 1. So that's y equals 2 minus 1, which means y equals 1. So when I plug in a 1, I actually got out a 1. Okay? And then my third number was, so this was the first one, this was the second one, and the third number we chose was 2. So it'll be, again, y equals 2x minus 1. So it'll be y equals 2 times 2 minus 1. So it'll be y equals 4 minus 1. And we all know that 4 minus 1 is 3. So it'll be y equals 3. So when I plugged in a 2, I got out a 3. Okay? And so I think, if I'm not mistaken, my math lab only makes you get 2 ordered pairs. But if you take a look, I actually got 3 ordered pairs. Ordered pair 1, ordered pair 2, and ordered pair 3. And you may say, what do you mean? I don't see ordered pairs. But if I make another table, or another column in this table. Let me get another color out and make this the X, Y, make this the order pair. So take a look. When we plugged in a 0, we got out a negative 1. When we plugged in a 1, we got out a 1. And when we plugged in a 2, we got out a 3. So those are 3 ordered pairs, gang. Okay, and so now I'm going to draw a coordinate plane. That's why I chose graph paper. Okay. So here's my little coordinate plane. I'm graphing this by hand for you. The first point we're going to do is 0, negative 1, which means we go over 0 and we go down negative 1. So that's order pair number 1, 0, negative 1. The next ordered pair is 1, 1. So I go over 1 on the x-axis. Again, this is the x-axis and this is the y-axis. I go over 1 on the x-axis, up 1 on the y-axis. So there it is, 1, 1. And then if I go again, the next one was 2. So I go over to 2, 1, 2. And I go up to 3, 1, 2, 3. And so then I would connect these ordered pairs. And I have a line. Okay, so that was graphing a line by plotting points. Okay, there is example 1. The second method that I told you was focusing on x-intercepts and y-intercepts. Okay, and so if we were in class, I'd give you a little bit more details, but just to keep it short so you'll actually listen to the whole video. An x-intercept, guys, means y equals 0. Just trust me. And a y-intercept means x equals 0. Okay? Put a big star on this. Let me highlight it. This is important. Okay? So let's do an example. Let's do example 3x minus 4y equals, let's say 12. And the directions would say, graph the x and y intercepts. Okay? All right, so again, if I do the first part, the x-intercept, I told you that the x-intercept meant y equals 0. So everywhere I see a y, I'm going to plug in a 0. So again, it was 3x minus 4. Oh, God, there's y. What did we say we're plugging in for y? 0 equals 12. Okay? So now we get 3x minus 4 times 0. We all know 4 times 0 is just minus 0 equals 12. So that's 3x equals 12. And y'all know how to get x by itself. Divide by 3, divide by 3, x equals 4. Okay, so hold on a second. When you plugged in a 0 for y, x was 4. So the ordered pair would be 4, 0. Again, x is 4 and y is 0. So that right there, gang, is the x-intercept. Okay. And now the directions ask for us to do the y-intercept as well. So we have the y-intercept. And again, that means x equals 0. Okay, so the equation was 3x. Oh, God, x. What are we plugging in? We're plugging in 0 for x. Minus 4 times y equals 12. Well, guys, 3 times 0 is 0. Minus 4y equals 12. Well, guys, 0 minus 4y is not 4y. 0 minus 4y is a negative 4y equals 12. And y'all know what to do. Divide by negative 4. Divide by negative 4. We get y equals negative 3. Okay? And so let's get our ordered pair. We plugged in 0 for x, which means 0 is x. And y is negative 3. And that right there, my class, is the y-intercept. Okay. And so now I'm drawing an order or a coordinate plane. Okay. And again, the horizontal axis is the x-axis. The vertical axis is the y-axis. And this point in the middle right here is the origin. Okay. And so let's plot these 2 points. 4, 0 means we go over 4. 1, 2, 3, 4. Up none. So that right there is my x-intercept. Like we said it was right here, x-intercept. The y-intercept is 0, negative 3. So I go over 0. I go down 1, 2, 3. 0, negative 3. I connect these 2 ordered pairs. And guys, you have a line. And let me warn you, if my math lab says plot using x and y intercepts, like I gave you in the directions right here that I'm underlining, and you do not plot the x-intercept and the y-intercept, my math lab will count it wrong. So make sure you follow the directions however my math lab asks. Number 3, the third method was called slope-intercept form. And I know that you know slope-intercept form from high school. Hopefully you remember is y equals mx plus b, but we'll get to that, okay? In order to know slope-intercept form, first I need you to know this concept called slope. Slope, mathematicians like to call slope lowercase m. And I know you've heard before that it is rise over run. So that's one way to talk about slope, rise over run. Another way to talk about slope is y2 minus y1 over x2 minus x1. Okay. And so before I can ask you to graph a line in slope-intercept form, I'm going to give you an additional example. So the problem could say, find the slope of 2, -3, and -4, 5. I'm just making up. No, let's do -4, 7 to make it a little different. Okay, so I've got 2 ordered pairs. And if we were in class, I would make you label this so we know X and Y. This is X and Y. And technically, guys, we call this X1 because it's our first X, and Y1 because it's our first Y. And this is our second X, and this is our second Y, okay? So if I go back to my formula, slope equals y2 minus y1 over x2 minus x1. We would plug in and we would get y2, which we called 7. The formula says to subtract y1, which is a -3. And I know minus and a negative is tacky, but I'm going to write it because the formula says to subtract and then the number is negative, okay? On the denominator, we start with x2. x2 is -4, and we subtract x1, which we know is 2, okay? And so in my head, 7 minus -3, minus a negative in my head, I'm saying is addition. So 7 minus -3, guys, is a positive 10. And -4 minus 2 is a -6. And I need you to reduce your fraction. So if you reduce your fraction, you get 5 over -3. And I think I've told you this before. I don't care if you put that -5 in, or the negative in the denominator, or if you put the negative in the numerator, or if you put the negative in front of the fraction, as long as it's only one negative, okay? So there is an example of finding slope between 2 ordered pairs. Okay, so now I can introduce another big idea, which is called slope-intercept form, which is what I was hoping to get to. Slope-intercept form, which I already said. But slope-intercept form, let me get another color out because it's so important, is y equals mx plus b. And you guessed it, this m right here, guys, it stands for slope. And this B right here, guys, it stands for the y-intercept. Okay, that's how uncreative us math people are. We call it slope-intercept form because it has a slope and it has specifically a y-intercept. Okay, and so I'm going to give you 2 examples of graphing this. So, number 1 example. Graph using SIF. Remember, slope-intercept form is what I said SIF was. And I'm going to say is y equals -2/3 x minus 4. Okay? So hopefully you recognize that this equation is already in slope-intercept form. Our slope, for those of you that want to identify it, is -2/3. And our y-intercept is -4. But my math lab asks for you to write it as an ordered pair usually. And if you go back up, if I scroll up on this screen, take a look, take a look, take a look. A y-intercept, I told you x equaled 0. So the y-intercept as a point is 0, -4. Okay? Okay, so if I plot this bad boy. Okay, let's plot this equation or this linear equation. When you graph using slope-intercept form, guys, I want you to start with the y-intercept. And the y-intercept is -4, so that's 1, 2, 3, 4. Put a point. And now we use the slope, and I deliberately labeled it because I wanted you to understand this is a negative slope. So positive slope, if you looked at the PowerPoint, positive slope goes up and right. So it goes up. Negative slope goes down. Okay, so this is an example of a positive slope, and this is an example of a negative slope over here on the corner. Okay, so if I have a negative slope, some kids get confused because they think you can't rise, but you can rise. You can go up 2 and over 1, 2, 3. There it is. Up 2, over 1, 2. I'd actually have to go over again, 3. But you could go down, down 2, and over 3. So here. And if you take a look, my line is definitely not perfect, but that is a negative slope line. Okay, so there is an example. That was an easy example, hopefully, because the equation was already in slope-intercept form. So you guessed it, number 2. Let me give you the equation that we talked about. Let's do something else. Let's do 2x plus 3y equals 6. Let's do that one. And I want you to graph it, again, using SIF. What's SIF? Slope-intercept form. But hopefully you realize that this is clearly not in the form of y equals mx plus b. In order to be in slope-intercept form, y has to be isolated, and y up here is not isolated. So if I write the equation again, 2x plus 3y equals 6. And let's try to get this y by itself. So you guessed it, we need to move this 2x to the other side, which means we need to do the opposite. So we're going to subtract 2x on both sides. Okay, 2x minus 2x is 0x. So that is gone. 3y comes down. Equals 6 minus 2x. And no, you cannot put these two terms together because they're not like terms. We talked about that in the last chapter. We're going to divide both sides by 3. And I get y equals, well, guys, what's 6 divided by 3? 2. -2, oh, I got another one with the -2/3 slope. That's fine. -2x over 3 is simply -2x over 3. And so I know this doesn't look exactly like y equals mx plus b. But hopefully you recognize the m is -2/3, okay, because it's the number with the x. So my slope, again, is -2/3. I did not mean to give you 2 examples with -2/3, but slope, but that's what we got. And b equals the other number, and the other number is 2 all by itself. And again, if we write it as an ordered pair, remember y-intercept means x is 0, so the ordered pair is 0, 2. Okay? So now let's plot this one. Okay, so if I come here and draw my axes in, again, I got an x-axis and a y-axis. I need to do a better job of labeling that. And we're going to start with our y-intercept, which is 0, 2. So 1, 2. Again, guys, the slope is -2/3. Again, I did not mean to do that, but we're going to go up 2 and left 3 because it's negative. Up 2 and left 3, again, because it's negative. If you want to, guys, you can be fancy. Go down 2 and over 3. I literally just plotted 4 order pairs. My math lab only makes you do 2. So I did extra work, okay? So there is your lesson on graphing using 3 different ways, okay? Thanks for listening to me, guys.